Your FPS counter looks fine. GPU usage is steady, CPU isn't pegged, temperatures are normal. But you still feel it. A small hitch when turning quickly, a brief pause when entering a new area, a random frame time spike during asset streaming. It doesn't show up in average FPS, it shows up in consistency. On modern Windows systems, especially with fast NVMe drives, these micro-stutters are often tied to how Windows handles NVMe power transitions and I/O completion behavior, not raw storage speed. Today, we're going deeper. 5 focused steps. 2 of them involve safe, controlled registry adjustments, not extreme tweaks, not risky overrides, but targeted changes that influence NVMe behavior at the OS level. Let's begin. Step 1. Adjust NVMe autonomous power state transition behavior via registry. Modern NVMe drives use something called autonomous power state transition, or APST. APST allows the drive to automatically enter deeper idle states when it detects inactivity. The problem? Games don't produce steady storage workloads. They produce bursts, small reads, pauses, more reads. If APST is too aggressive, the controller drops into deep idle between bursts, and each wake introduces micro-latency. We're not disabling power management entirely. We're controlling how aggressively Windows allows APST to engage. Here's how. Open Registry Editor as administrator. Navigate to this path. If the device key does not exist, create it. Inside that key, create a new dword 32-bit value. Name it Enable APST. Set the value to 0. What this does? It disables autonomous power state transitions at the Windows driver level for NVMe devices using the Microsoft Storn NVMe driver. Why this matters? Instead of the drive deciding independently when to drop into deeper states, it stays in higher readiness levels, reducing unpredictable wake latency. Important limitations. Best suited for desktops. On laptops, this increases idle power usage. If your SSD uses a manufacturer-specific driver, like Samsung NVMe driver, this may not apply. Reboot after applying. This does not increase throughput. It reduces deep idle transitions that can introduce frame time spikes. Step 2. Tune NVMe idle timeout via power policy. Controlled exposure. Let's clear up something important. SSDs do not need traditional defragmentation, but that does not mean the Optimize Drives tool is useless. On NVMe drives, Windows Optimize does 2 critical things. Sends trim commands, performs storage slab consolidation when needed. If trim isn't running consistently, deleted blocks remain marked as occupied. Over time, the controller has to work harder during write and background cleanup operations. That increases write amplification. And during gaming, background garbage collection can collide with asset streaming. That's where unpredictable frame time spikes appear. We're not trying to defrag an SSD. We're making sure Windows is maintaining it properly. Here's how to check. Open Start and type Defragment and Optimize Drives. Open it. You'll see your drives listed. Look at your NVMe drive. Under Media Type, it should say Solid State Drive. Under Current Status, check Last Run Date. If it hasn't optimized recently, click Optimize. On an SSD, this does not rearrange files physically like on an HDD. It sends trim commands and ensures the file system metadata stays healthy. Why this matters for gaming? Modern engines, especially Unreal Engine 5, constantly allocate and delete small data chunks. If trim isn't active, the SSD's internal garbage collection becomes reactive instead of proactive. Reactive cleanup equals latency spikes. Proactive cleanup equals predictable behavior. Now, one more thing. Click Change Settings. Make sure Run on a Schedule is enabled, frequency weekly. That's ideal for gaming systems. Step 3. Improve interrupt servicing consistency under load. NVMe drives use MSI/MSIX interrupts. Under heavy CPU load, especially on 6-core and 8-core systems, interrupt servicing can become slightly delayed if background processes compete aggressively. We won't manually reassign IRQs, that's outdated. Instead, ensure game mode is enabled. Settings/gaming/game mode/on. Then enable hardware-accelerated GPU scheduling if supported. Settings/system/display/graphics/default graphics settings. Why? Game mode reduces background task priority. HAGS reduces CPU overhead for GPU command submission. Together, they increase the likelihood that NVMe interrupts are serviced immediately during gaming. This is about scheduling headroom, not FPS gains. Step 4. Stabilize memory plus page file behavior. Sometimes what feels like SSD stutter is actually memory pressure triggering storage bursts. When RAM usage spikes, Windows activates memory compression, page file reads and writes. If the page file is misconfigured or disabled, frame time spikes can worsen. Step 1. Open virtual memory settings. Go to System, Advanced System Settings, Performance Settings, Advanced tab, Virtual Memory, Change. Step 2. Configure properly. If you have 32 GB plus RAM, leave page file set to System Managed. Ensure it's located on your fastest NVMe drive. Do not disable it because you have enough RAM. Windows still expects it. If you have 16 GB RAM, make sure the page file is enabled, preferably System Managed on your fastest SSD or NVMe. If you previously disabled it, re-enable it and reboot. What not to do? Do not disable the page file entirely. Do not put it on an HDD if your game is on NVMe. Do not set extremely tiny custom sizes. Disabling the page file often makes stutter worse, not better. Why? Games don't allocate memory evenly. Unreal Engine titles especially can spike unpredictably. A properly configured page file prevents emergency memory compression bursts that can cascade into storage stalls. We're eliminating secondary bottlenecks. Step 5. Reduce store port completion latency sensitivity, registry level tuning. Now we address something more advanced. Windows communicates with NVMe devices using store port. Under certain power conditions, store port can allow deeper idle sensitivity that increases completion latency variability. We can adjust a controlled parameter that influences idle responsiveness. Open Registry Editor. Press Win+R. Type regedit. Press Enter. Navigate to this path. If Parameters does not exist under Store Port, create it. Right-click Store Port, New, Key, name it Parameters. Create the value. Inside Parameters, right-click New, DWORD 32-bit value. Name it Enable Idle Power Management. Set the value to 0. What this does, it reduces store port level idle power management behavior, keeping storage request handling more consistent under fluctuating load. Why this matters? It prevents additional OS-level idle handling on top of NVMe controller-level power states. We are reducing stacked latency layers.
Smooth systems aren't built on extreme tweaks. They're built on understanding where milliseconds are lost and eliminating unnecessary transitions. If you value deeper, system-level optimization focused on real responsiveness, consider subscribing. And always, change one variable at a time. Measure results. Prioritize stability over hype. Thanks for watching.